Holy database Batman, it's time to get jiggy with our data and select statements.
Hi
Anybody like
guys!
pepperoncinis? We are Pelangelis. I am Lauren.
I'm Aga.
And today we get to look at crazy schema type stuff and how you can be a badass at work. Maybe you see these sorts of charts over at the place where you work, which really is an entity relationship diagram. How different tables relate to one another that might be filled with all kinds of interesting data.
We know that so far you've been only throwing darts at them thinking this is the real way to use it. But surprise! You can do different things with database.
Yes. We have pulled information from 6 real restaurants out in Krakow, Poland. So that's why we've called it the Jamie video, after Jamie Oliver, the naked chef. And we'll be querying meals from those restaurants, like their menu. We've got them carved up into 2 different tables, and we call that sort of data normalized. So we have somebody that has put together these couple of tables for us. Stuff that used to be in a spreadsheet, it's now been carved up into 2 different tables. So it describes 6 different restaurants and how they tie into 22 different meals.
We would like to present you how you can write a basic select statement, where select statement is pretty much how you ask your database to give you back information that you want to see. Later on, we would like to show you from this information that we get how to see something more specific, how you can see meals for just one given restaurant instead of seeing all of them. Later on, we would like to introduce you to functions, how we can count stuff together, how we can find the average price of a meal, or even the maximum and minimum one. There is 5 aggregate functions that we will tell you about. When we are working with functions, one of the essential things that we need to remember is grouping. Group by allows you to see multiple lines. Let's say average price for each restaurant, we would have 6 lines. So for that we need the group by. And to become really powerful, we will teach you how to join tables. Instead of working only on one table of meals or restaurants, we will show you how you can find the name of your restaurant and then what is the cheapest thing you can get in this place, or the most expensive one as well.
Ooh, living large.
And in the end of that video, we want to mention something about NULL, the very special guy that wants to be different.
When you have an absence of data, something that is unknown, then that's where NULL would be usually used. In our case, we have a meal that we don't know the price of. The kimchi soup, it ends up that it has a missing price. So here's the data that we'll be working with today. We actually have 22 different meals, so this is not an all-inclusive list, but we find then a list of different meals, their prices, and if they are or are not vegetarian, and then also what restaurant that they come from, along with the address. Overall, if we were to carve this up into separate groupings of data, what are the groupings that we would find of all this data?
I think that we could try to skip all the repetition that are existing in this spreadsheet. So we can see that here we have few times mentioned Zapiece, which is the name of a restaurant, as well as other restaurant, Gospoda Coco or Skateburger, for example. We can try to put it into tables in a database. And in this way, we don't have to repeat the name many times. We don't have to repeat its address because it belongs to the restaurant that we are talking about. Also, we can create a table for meals and then tie them together with restaurant.
So ultimately our data becomes in 2 different pots, 2 different sets, 2 different tables. We carve it up as being a table about restaurant and then a table about meal. And we tie these things together with numerical codes, a primary key and a foreign key that will relate each meal to a given restaurant. Such as for Skateburger, these 3 things, salad, the backside, and the ollie, are all different meals that you can find from Skateburger. We have an ID of 4 that ties those things in.
We're supposed to make a select statement or what?
Oh, I think that would be a good idea. So let's see what we can build now that you've seen a little bit of the schema. Here is just the terminal where you can run a thing called PSQL. And once you're on board, you can list out all of the databases in your environment with \L.
PSQL stands for
So PostgreSQL, just the terminal-based environment. Type in what you want. Now that I have seen the list of all these many, one of these guys is called Jamie, of these very many databases. That's the one that we'd like to light up right now, so we can now connect to the Jamie database with \c. These are the only kind of commands that you can do in PSQL that don't have a semicolon at the end. So that's kind of an interesting thing. We usually have to have a semicolon at the end. So what do you think we should do first in terms of getting some data?
Let's write a query that will show us names of restaurants.
So we have this as being our very first select statement. This whole video only really showcases how select works. We're not changing data, we just want to see it. So this is how we would visualize stuff. We always have that as the front, the keyword select, and then we can have this select list that shows us a comma-separated list of all the stuff we want to have back. In this case, it's just name. The from clause would say which table we want to pull this information out of. So we take this from restaurant. We have made this so that the table names are all lowercase, so you don't have to worry about uppercase, lowercase. Everything on the table names and the column names, all of them are just lowercase like this. There we have it.
Well,
what next might be more interesting?
I would like to see what are the meals that this restaurant offers.
Pick one of these then, and let's find out. Or do you want to see like all of the meals all shown?
Maybe let's start just with one restaurant because it's easier. I want to know Lauren, what is your favorite one?
Oh, I like the skate burger.
Just because you can pronounce it.
Okay, that's
count.
true.
It
doesn't count. You're right. So what's your favorite one?
How would you pronounce the 1, 2, 3, 4, 5th one?
Glonajad.
It's Glonoyad, yeah.
Glonajad.
Glonoyad.
All right, so we first need to find the ID. So I think that I will rerun the last select statement, but also then see the ID so we can identify from Glonajad what is its ID. So I'll do the up arrow on the keyboard, which brings back the last command, and then I can edit the select list so it also includes ID.
This is nice. So the first part of our select statement, whatever we see after select and before from, this is a list of things that the computer will bring back to us. This is actually the result that we will see on our computer.
Now we find then that Glonajad's ID apparently is number 5.
So it's a primary key on that table, but on the other table of meals, it's going to be a foreign key.
Oh, that's right.
Woo!
We've seen that Glonajad was ID number 5, but then what is the foreign key called over on the meal table?
Yeah, restaurant ID.
Restaurant ID. Nice.
You need to point out where it comes from, so the name of a table as the first part of the column name. And then ID, isn't it how it goes? Like, if it's a foreign key, it will take a name of the table that it comes from. So if it relates to restaurant, it's going to be restaurant and then ID.
If people have been nice to us, then yes. And people should follow those rules, but are they always going to? Like, you could have called this XYZ ID, just to be, like, a crazy.
Or it could be you're a dumbhead.
Yeah, you're a dumbhead ID. And then just those people who want to be obscure would then know that it's XYZ ID instead of really restaurant ID. But yeah, hopefully people are following some sort of rhyme and rule and having it that the table name would be the thing that is at the first part of the name of the key.
Okay.
So in this case, they have been nice to us. So we're selecting all of the names of meals, and then we want to filter it down only just based on Glonajad. So it's where restaurant ID is equal to 5. Note the semicolon at the end of all of our different statements here.
It gives us a winky. It's like,
Little,
I know what you mean.
yeah, we're on terms. Apparently these 4 are the things that come from Glonajad.
Vegetarian.
All right, now we can also add some other things that would be in that same table. So what extra information might we grab for a given meal?
We may be interested in the price of a given meal.
Oh yeah, what kind of money do I have to lay out for this thing?
Or if you hate vegetables, you want to know if it's vegetarian or not, because...
Maybe there's then both of those we get. To get a list of all the different columns that are found from a given table, it's kind of easy to do this little trick. Select splat means to show all of the columns. That's a wildcard sort of a thing. Means all columns. So we'll select splat from meal, limit 1. From this, we now see, and of course, like the street cleaners come by at the exact moment that I'm trying to do a great video.
They shouldn't do that on Sunday.
Those guys are really busy. Apparently, because of the whole rugby finals, it's been a lot of people throwing stuff in the street, and then the street cleaners need to come up, like some puke on the street from last night.
Or some people just randomly laying on the street as well.
Yeah, need to clean up the people that are just laying around.
Wash them nicely.
So we apparently have, oh, you know, the IDs are a little bit goofball on this. I should worry about that. Anyway, the name, we have the name of a given meal, and description, and price. So this is all the different columns that we could bring back. You would mention that you want to see price and true, false, is it a vegetarian dish? So let's go ahead and do that. I'll do the up arrow to get back that select statement from before. Not anymore just only seeing the name, but also including the price, and if it is or is not vegetarian. Coders will oftentimes put this kind of a prefix on stuff that's like a true-false idea. It's called a Boolean column. It can be true or false, a 1 or a 0, a yes or a no, that kind of two-state possibility. Apparently all of the stuff from Gloniad is vegetarian. In fact, it is a vegetarian restaurant, so I guess that makes sense. What about getting stuff from a restaurant that doesn't have all vegetarian dishes? Like, oh, my favorite.
Skate burger.
Skate burger.
Okay, you can get that.
So we'll first find out what is the ID of the restaurant that is Skate Burger. Doing the up arrows a little while, we get back to this previous command we had, the ID and the name of the restaurants, and apparently restaurant number 4 is Skate Burger. So we'll just change out this query to say instead of stuff from restaurant number 5, we'll say that we'd like to get information from restaurant number 4.
It's a fun code, like instead of saying names of restaurant, you're just putting numbers. So if like you had your little friend from the childhood and you were playing this code games, like when you don't want everybody to know what you were talking about, and it's like, hey, you know number 4? And then, you know, so this is like playing
It's your
a
friend
game.
Larry, it's Larry's
Yeah.
number 4, yeah.
Jimmy is our friend here, and we're giving code to him.
Yeah.
It's like, hey, you Jimmy, tell me about 4.
So let's find the average price for all stuff that is vegetarian,
Nice.
where the is vegetarian is equal to true. And then we'll find the average price for the stuff that is not vegetarian. So if we just take a look at this, if we add 18 and 8 of the vegetarian stuff, that's 26. And so if we divide it by the 2 things that there are, so the average price is apparently 13.40. And then we'll average this one after that. So let's find out if we can just focus in on these 2 dishes alone. What else can we add to the where clause to be able to make it so it only looks for stuff that's vegetarian?
We need to first say and, which is a keyword, and then the name of a column that we are looking at, so is vegetarian, equals, and then true.
And there it is. This is a special sort of keyword to indicate Boolean ideas of there could be true and also you can use false. It just matches up to these T's and F's that we find that it gave back here. Kind of like Jamie's secret code there, you know, amongst friends.
Okay, but it doesn't show us the average yet, so I'm excited about it.
Now, I wonder what we can do instead of having a listing of all the different detail about the dishes, these columns coming back. What could we put in here to be able to find that average, I wonder?
We need to put a function that it's going to count it for us.
Ah, so there are several of these functions that will give a subtotal of some kind. We call them aggregate functions. So we could count up how many, and then it finds that there are 2 vegetarian dishes there. Functions always utilize parentheses. That's one of the dead giveaways. You will find there's some name in the function, and then something in parentheses afterwards.
But it's the same like everywhere, isn't it? Function in math always use parentheses as well.
Oh, true. There's only a few languages that get a little bit squirrely on that, like Visual Basic and Ruby, where you don't have to put the parentheses, but you can if you want. We can also use the average function, which is just shortened out to be AVG. And we want to find the average of one certain column. What is the column that we want to put in here?
Price.
I love it. Apparently, we find that the math has been done and the average price ends up at exactly 13, just what we had calculated before.
That's very unlucky.
Oh, those poor vegetarian dishes at Skate Burger. Let's find the ones that are the non-vegetarian.
Let me
For
do
you-
that.
For you carnivores out there,
Yeah. So let's.
what's the average price of those guys?
Mm-hmm.
Oh man, 20 pounds. So you're paying a lot more money if you're a carnivore. 20 and a third. So what kind of things can we do with this new capability? To be able to count up things or to average things? Let's think outside the box for a moment.
We can check what is the average price of meal in a given restaurant.
This is a very good idea.
Yeah, but wait, like when we go back to the restaurant, it doesn't have a price on it. The price is only on meal.
True that.
Okay, so we have to go to the table of meals, which have a price, and then work on their average.
Yeah, so we have half the information that comes from the meal, and then the other part of the information coming from restaurant. So 2 sets of information. And in fact, you can see the schema as well. We have this picture where it shows restaurants have this kind of information, name, description, and address, and then meals have this information, name, description, price, how spicy it is a number for us, and then if it is or is not vegetarian. So this is a fun query then, to find the average price from just one restaurant for all the carnivorous stuff. Why don't we change it around now, just so we're seeing the average price across all dishes at the restaurant. So, for restaurant ID 4, 17 zł 40 grosze for each of the dishes.
Baby złoty.
Baby złoty, yes. We call the little penny pieces over there baby
Grosze.
złoty. So, we can find for each of the restaurants what that average price is. Apparently, that Glonayad restaurant has a little bit cheaper overall average price. Restaurant ID 2, whatever it is, has about in the same ballpark. Restaurant ID 1, which is Varstad, I believe,
Yeah.
it's a little bit more, 1762 on average. But I want to find, maybe with one query, how can I get all of this information all at once? So I want to first take the meals and group together by restaurant. I want to find out, like, for all the stuff that comes from restaurant number 1, what's the average price there? Or for restaurant 2, what's the average price there?
But you just sold yourself. You said group by something.
Oh no, did I let the cat out of the bag?
Yeah.
There's a little secret that we'll show. So instead of this where clause, which is to focus just on one restaurant at a time, I kind of want to show the restaurant ID over in the select list. So let's make that happen, but then see where there's a little bit of a clash. You see, these aggregate functions, like count and AVG, they're supposed to bring back only one response, whereas normally putting in the name of a column, such as restaurant ID, is supposed to bring back one response for each of the meals.
Let's see it crash.
Yeah, let's see it burn and die. And it explains restaurant ID, I can't make that pair up with this average thing because it's different ideas. This is an aggregate, just bringing back one response, and this is something which should have brought back one response per meal. So it says then that the restaurant ID must appear in the group by clause.
I like to explain it the way that this language is like a man, so it's very specific and needs to have things directly presented, said like, this is what I want from you, this is where you go to look for it, and by the way, here are little hints how you do this. If you tell things that are a little bit ambiguous, then he just like, I don't know what I'm gonna do, like, what do you want from me? So he even barks out what he wants exactly.
Oh, sweetie, I love your little examples. Look at how she understands me like that, huh? So we'll do the up arrow, and yeah, just like you need to explain things very clearly for me, it's true, apparently it must appear in the group by clause. So okay, group by, the thing that it explained was restaurant ID. So group by restaurant ID. And now we find each of the restaurant IDs, the foreign key info there, tells us what the average price is.
And now he's happy to provide all the information he knows.
Yeah, we can prove it out in fact, like Glonayad apparently is 933, like we'd seen before. Vorstadt is 1763 on average, rounding up, etc. So these counts seem to be all right, these averages. The final piece then, this is not very understandable by us. These codes, we know that they relate back to restaurants, but how can we instead see really the name of the restaurant?
We need to tell Jimmy to show us the name of restaurant. Jimmy is a special codes guy.
Magic Jimmy, get on the scene here, will you? So because we have a one-to-many relationship between one restaurant has many meals, perhaps we can use the foreign key to be able to relate somehow back to that original restaurant. What we're getting to is why we're so excited about having SQL. Its power lies in being able to count things up for us, average things, but then also relate multiple things together. So putting all of this together, we like to see the average price of meals from each of the restaurants involved. The group by was able to show us that average appropriately, but now we somehow just have to tie it back into restaurant. So let's cut loose from being able to do averages and stuff for just a moment and see how we might have a query that would show us the name of a restaurant and then the name of all the meals that come from that restaurant. So it's the idea of having, let's say, ID and name from restaurant. So there's those 6. And then if we select name and restaurant ID from meal, and maybe we'll just show the first 5 on that, we see that mushroom pizza comes from Vorstadt. And how do you pronounce this one? This beetroot soup?
Yeah, it's barsht.
Barsht comes from
Zapieczek.
Zapieczek.
Yeah.
And these two come from, so all 3 of those guys come from Zapieczek. So we have these codes as somehow relating back, just like that poster had shown a moment ago.
We could just draw the arrows now. Bang, bang, bang.
Yeah. Those codes are lining up. This is what kind of key in the meal?
This is a foreign key.
Ah, and then this guy?
This is a primary key for
Primary.
restaurant.
So we have a primary that relates to a foreign.
This is a spy. The foreign key is a spy.
Ooh. A little sneaky. Taking a look back upon the original restaurant that it came from. So our idea is to put both of these things together. And this is where we start to see some dotted notation. Some, what do we have from one table versus another? So from the restaurant table, we want to see what?
Name.
Name. And then also, from the meal table,
What do we want to say?
I think also the name.
Okay, yeah. So this is how we do that. At first, we put the name of a table, then we put dot, and then name of a column.
As we write it this way, it'll need to tie both of these ideas together with those keys. So we're really taking it from 2 places, one table and from another table as well. And how do you combine those thoughts together?
So we need to join them.
Join. All right. So we can start from either of these sides to be able to put this together.
Let's talk about restaurant at first.
All right, restaurant.
And then we need to join the
So-
other one.
Inner join, the other one, meal. And then we need to educate it about how it gets tied together.
Yeah.
So what do we do?
So we need to... So what we have in common are the foreign and the primary key. They exist in both tables. So we need to take a primary key from the restaurant. So we say restaurant.id is the same number, so it equals to a meal, which is the name of a table, dot restaurant ID.
Just as simple as that, huh?
Yes.
Indeed. So now we find that Vorstadt has those 4. And so forth.
So now we combined 2 tables. We have both restaurants and meals shown on one page.
Ultimately, we had kind of threatened to be able to do some group by as well. Can you imagine combining the power of join along with group by?
Well,
What if
I
wanted to
can.
find, like for each of these, let's then show the price of each of these dishes as well. So we'll rewrite this query. By the way, when you have this running off the screen like this, and if you end up having this colon down below, it just means that it filled up the screen, and it has more to show you, and if you press the space bar, then it'll do another page. So I'll press a space bar, and then the rest of them have come out now. 22 total responses. So apparently across all of my restaurants, there are 22 different meals that we have in this database. Doing the up arrow to bring back the last command, not just the meal name do we want to see, but as well the meal price. We can pick as many of the columns as we wish from either of the tables to be able to show in this. Pressing enter, there it has it, now also showing the exact price of each of these meals.
Can we list it so it goes from the cheaper meal to the most expensive?
Ooh, cheapest to most expensive, so kind of a sequencing.
Yeah.
We can use what clause for this?
Maybe we need to order that, so order by.
So we want to see it by the most expensive to least expensive.
Mm-hmm.
All right, so we want to order it by meal.price, but if we just run it this way, it goes from the cheapest, Weisvoda for the beetroot soup, over to the most expensive, which is 22. Apparently there's a tie on that one. Over at Skateburger, they have the most expensive stuff apparently. And then one of our things doesn't even have a price at all. We have to figure out how expensive the kimchi soup is. It's missing a price, and they just threw it in at the end just for grins.
You just get it for free.
Hopefully, man, I'll just go in there with a smile and see what they do. So ordering it by meal price, this has been an ascending format, so from least to greatest.
So this is where you need to have a cheap lunch. But now let's see, if you want to take your girl out for a date, you will change the order.
Yeah, that's right. You don't want to look
or your
like
mom
a cheap
for her
bastard like
birthday.
me. Yeah, oh, we love mom. So descending would go from the most to the least, as you might expect. And if we run it this way, now it's turned around, and the most expensive stuff on the top. Incidentally, if we only wanted to see like the top 5 most expensive, we could do that limit thing and then put in a number that we see fit there. It has put in this kimchi soup that doesn't even have a price, just not knowing where to put it essentially. So we'll see in a little while how to weed out those that are missing a price. So now apparently at least then we can see the price, we can order it by most to least or what have you. Now, what else? We had threatened to combine forces between our grouping
and the average price. So we want to see the average price per meal per each restaurant.
Yes, and let's get back to that query that we had a moment ago that was doing grouping. Not involving a join yet at this point, but about to put this together, but for a given restaurant ID, show me the average of the price from
meal.
And then we had to do a grouping on which of these two ideas?
The one that is not a function, which is restaurant ID.
Ah, the one that is not an aggregate. Group by restaurant ID. This is our query that we had a moment ago. So now, can we put both the join and the group by into one big query?
Sure, we can.
I'll be writing this on multiple lines just for clarity's sake. So I'd like to steal this as kind of a starting thought, and then I'll paste that in to be the first line, but edit it, instead of being the restaurant ID, I want the restaurant dot name.
So now we've put the dot instead of the underscore. So this indicates that now we are not talking about just a column name, but it is a table name. That was confusing to me at the beginning. Like sometimes there is an underscore, sometimes there is a point, and I was confused with it. So just to remind, the point means that we are talking about the table name, and whatever comes after the point is a column name, but sometimes in the column name you will see some underscores which will tie words together. So here we talk about a restaurant ID, which is a foreign key, and we want to make it as descriptive as we can. So that's why the underscore is there, to tie these two words together.
Yeah. It could have been named anything. It could have been called XYZ ID or whatever. But thankfully, the folks who put this database together decided, well, let's have it to be easy so that this foreign key, it does relate back to a restaurant. The name should then be, how about restaurant ID, so we're not confusing people here. We want to make it as easy as possible. In that same light, by the way, what could we call this price?
It has to be the table name first, so meal.price.
Aha, that's the better way to state it. Very nice.
In fact, when I'm putting my queries together, even though I'm working on one table, I like to put the table name there anyway, just for practice. So, for example, in the previous query, I would personally put the meal dot before the column names.
So this guy becomes meal.restaurant ID, meal.price. It's already there, and also group by meal.restaurant ID.
Just for practice and just to make it clear and easy.
Makes sense, because if you're going to then start to introduce multiple tables later, you're already prepared for that, and your queries are ready to go.
It's the same idea like testing in the other video. It's like it's good to start with the good habits. So let's start making with the table name, or let's start making Ruby applications with testing.
Very good point. Now we'll have this as being our first line. Note that we have not put a semicolon in there yet, which means the command is still going. We're having it on multiple lines this time.
And
I'll
now,
also indent, just trying to have some good form here.
you just pressed what? Enter.
That's right, enter.
And it brings you to the next line.
That's right, and it also indicates things are continuing because of this dash. So what comes next? A select statement has multiple clauses that it could have inside. Our next thing that we need to do after the select list is...
From. Point out where to look for the answers.
Okay. I'm going to steal the from clause that I had from that last time that we joined things. So I'll scroll up here, and here is the entire from clause with everything represented from restaurant and joining meal on this whole idea. So that entire thing becomes the from clause. Just copying that to the clipboard by pressing Command C. Now I will paste it in right here.
So on in the join clause, this is indicating on what conditions we are joining two tables. And
Yes.
it must be there. Like, it has to be there, otherwise it will freak out.
Yeah, it needs to know how to tie these guys together. After this, we also have what other thought happening inside of this select statement.
We wanted to do the group by.
Yes, and we cannot switch the sequence here. After the select list, we then can have the from, but nothing else before that. The from needs to be at this point, and then after the from, you can have other things like we've seen the where clause or the order by. Those have to come later. Sequence matters on these clauses.
In fact, we have the board that we can present.
Oh yes,
Will be easy to download it from Polangeles.
in all cases, we want to group by.
Whatever is not an aggregate function.
The only thing not an aggregate here is restaurant name. So group by, and the things that count are only the things in the select list and a where clause. So the on has these other non-aggregates. It doesn't matter because this is how the table's gotten tied together. We don't have to worry about these as being part of the group by. The group by only relates to things in a select list or the where clause. So in this case, restaurant.name. And then that's enough to be dangerous at this point. Putting a semicolon to say we're done with our statement, it now comes back with the name of the restaurant and the average price.
Wow.
Are there any other aggregate things that I might be able to do other than average?
You showed already that we can do the count. So how many meals each restaurant has?
I would like to now try that out. Pressing the up arrow, it brings back that whole entire select statement. In the select list, I can add any other aggregate that I want, such as count of splat. This is to mean for any row that has data. So any row that has column information whatsoever. The splat is to mean all columns. So look across all columns. If there's a restaurant that has information about it, my gosh, then count up how many times it appears. So how many total meals? Any other sort of aggregate functions that I can use. In fact, maybe we should mention here that there are 5 common aggregate functions. Average and count are 2, and then we have
The maximum and the minimum.
max priced item and minimum priced item. So maybe we do max of meal.price and a min of meal.price. The other one of the 5 that we could do is sum, which doesn't make a whole lot of sense. Like, what's the total cost of all meals if you were to sit down at the restaurant and say, I want everything? What would you be paying for that? That doesn't make a lot of
Bring it
sense
all.
here. In many cases, though, if you want to total up something, like maybe it's bills or something, you have a spreadsheet about how much you've paid for electricity over the past year, or cell phone bill, or whatever, automotive maintenance,
Shoes and purses.
shoes and purses. So you could total that up by having a sum. On a per month basis, you could total it, or a per category basis, like utility bills and stuff.
I was wondering about a splat that you are using in this query. Because here we are using splat for count and it's a part of a function, but then earlier today you were mentioning that if you do select splat from some table, it's gonna bring up all the column names and all the information. So can you explain again, like how does it work, like why we have splat in two different situations here?
Yes, this is a really kind of a huge point. And actually, to experiment for a moment, let's see something that we can have differently. By changing out this splat, we can focus it on places in which we actually do have data. Like by doing count splat, we had said before this means all columns. It does not mean all rows. It just means all columns. So do you recall that there was one dish that did not have a price?
Yes.
From the Oriental spoon, there was one dish that had a null price. So right now, we are counting up how many dishes have come from Oriental spoon, and it says 3. But let's go back here where we had the splat, and we'll change it out to count up how many things actually have a price. So meal.price. We know that one thing is missing the price. Now, from Oriental spoon, it has changed its tune, and it says that we just have 2 things. We have only counted up stuff that really does have a price. Back when we had splat, it was counting up anything that had any data whatsoever in any column. The splat to mean all columns.
Does it change the average price in this case?
Has it changed the average price? No, it does not. So the average price always had skipped past the row that said I don't know.
Because there was no data. If that was 0, then it would change it. But
That's
that
correct.
Was nil.
Yeah. So nulls are a very important and oftentimes very pesky aspect of working with select statements. Here's one more thing that we can do, by the way, to find all of the things that have a null price. So let's do select show me all of the columns from meal where price, you would think it would be where price equals null.
But null is special.
Null is kind of weird.
He's a different guy.
So instead, we would say where price is null. That's the right way to test to see where things actually are null. And here we find the kimchi soup. We just don't know how expensive it is.
But we know that it's vegetarian. At least we know something.
Yeah. So in this video, we've seen, first of all, how we can carve up data into multiple different tables, as it were. A little bit of just simple select statements, limiting down to maybe 5 rows or 1 row, showing with the splat all of the different columns. Using what clause to be able to filter?
Where?
The where clause, to see all the vegetarian or just stuff from one restaurant. Getting aggregates using special functions. Count, average, later we had min and max. Use of group by, so we can carve up things on a per restaurant basis. And then we wanted to see not just weird codes, like restaurants have that foreign key number thing, but being able to join the real names in there. Having the restaurant table joined in so we saw the names of the restaurants involved. Finally, how to work with null.
The special guy. We could teach you more, but we're hungry. It's lunchtime.
Come on out to philangelist.com if you'd like to see some more about databases and also other technologies. We do lots of different videos.
But we love database most.
True, actually.
Sorry.
Don't tell the other guys.
Yeah, don't tell them. Rufus will be jealous. Thanks for watching Robi Pierogi.